before. They're buying down the cost of electronics, of AI, of robotics that will enable for very small, very powerful, low-cost, low-power spacecraft. These are essentially the kinds of technologies that at Singularity University we study today. The second is the availability of commercial space launch. It's finally arrived. Multiple companies like SpaceX and Jeff Bezos with Blue Origin and Paul Allen with the Straddle launcher have invested and committed billions of dollars. These also demonstrate the ability of small private teams to do things that were only once in the realm of governments. The third powerful force are a new generation of risk-tolerant investors. So Eric's going to speak about our investors and who they are and why they're involved. But we're also seeing a new generation of centimillionaires and billionaires who are now investing in space. There are people like Elon and Jeff and Paul, who I mentioned, and Richard Branson in the launch industry. There are the dozens of extraordinary private individuals who are investing in the Google Lunar X Prize teams that are going to the moon. This is smart money investing in one of the largest commercial opportunities ever, going to space to gain resources for the benefit of humanity. The Earth is feeling a resource pinch, and ultimately, we have the ability to turn that which is scarce into abundant, and so now is the time that we need it most. Finally, we are living during a time when we are directly in line with NASA's policy. NASA's goal of extending human presence in space, of going back to the moon and Mars, and partnering with private companies to do things such as what Planetary Resources is planning to do, to help extend human presence in space. So I'd like to talk a little bit about how Planetary Resources got started. Eric and I have been business partners for over 16 years. We co-founded Space Adventures together. Eric was a part of the early team at Zero G and X Prize, and we've always shared the dream of opening up space. And it was a little over 3 years ago where we had a meeting and we sat down and said, what's next? Commercial private spaceflight has been great. It's working. We have thousands of people now buying tickets to go to space. But what's next? What's going to drive us beyond? And both of us found a passion for going to really hook our, if you would, our engine of opening up space to gaining access to the resources. This is the engine that will expand the economic sphere of influence beyond low Earth orbit, beyond geostationary orbit, to gain the resources of space. So people ask, can it really be done? How difficult is it? Let me say it can be done, and yes, it's very difficult. There's no question. We're talking about something which is extraordinarily difficult, but the returns economically and of benefit to humanity are extraordinary. So when I think about a proof case of what makes this possible, why do I believe this is doable? You know, recently at X Prize, we created a partnership with Shell to help underwrite our exploration of space. As I think about what Shell and the other exploration companies have done, they've literally created robotic cities on the bottom of the ocean, 10,000 feet below the ocean surface, fully robotic cities that then mine 5 to 10,000 feet down below the ocean floor to gain access to oil. These are commitments of $5 to $50 billion in each of these platforms. It's extraordinary what humanity can now do. For me, that kind of work makes going to the asteroids to extract resources look easy. So, in conclusion, as we look towards space for these resources, we really take a page from the playbook that's been used by humanity century after century, millennia after millennia, to go looking for these resources to help expand humanity's footprint into space. We're implementing the vision of great writers and thinkers like Tsiolkovsky, Heinlein, Clarke, and academics and visionaries like John Lewis, whose seminal book, Mining the Sky, helped set our vision. So I am very proud to be here on stage today announcing this company, and I'd like really at this point to introduce one of my closest friends, an extraordinary business partner, Eric Anderson. Eric and I have known each other for 16 years. He is the co-founder and chairman of Space Adventures, and I really want people to realize the extraordinary work he did there. he has gone out and privately sold over $500 million of human spaceflight missions as part of that company, an extraordinary feat. He is the CEO of Intentional, a company headquartered here in Seattle, which is a pioneer in the future of software, where he's working with his partner in the Microsoft chief architect, and of course Planetary Resources investor, Charles Simoni. Finally, along with me, he is a proud co-founder and co-chairman of Planetary Resources. Would you please all welcome Eric Anderson.
Okay, well, this is super fun. The day, so when I was a student studying aerospace engineering at the University of Virginia, I can only have imagined the time when I would stand in front of an esteemed audience and talk about the launch of an asteroid mining company backed by some fabulous financiers and entrepreneurs and visionaries, and working with some of the greatest people in the world. So it's a real privilege and a dream of mine to be here in front of you talking about this, and I hope you'll share this spectacular moment with me. I have absolutely no doubt that the announcement of this company will be a seminal event in the future of entrepreneurial space and in moving off the planet. Not necessarily because I think this company will be the most successful. I certainly hope it will be, and we're going to work to do that. But because I'm sure there'll be many who follow, and as we have started the market and the move towards commercial human spaceflight, this will now create a new industry that's even bigger by an order of magnitude or 2 orders of magnitude. And that is the industry of what we need, of resources, of energy, and moving from an industry where that exists on the planet to one where it exists in the solar system. So we're now going to bring the solar system within our economic sphere of influence. And so I'm going to talk to you about the business side of this for a little while. We're going to talk about four areas. And at first, I'm going to tell you about the value of asteroids. So if we're standing here up in front of you, considering this grand adventure to talk about resources from space, why is it and how is it that we came to understand and to believe that the asteroids were a great place to start? And the fact is that asteroids, coming from the very, very early part of the solar system, the very formation of our solar system, have existed for literally billions of years and have some of the most interesting and valuable materials that we will need, not only in the future in our future in space, but also for our future on Earth. Okay, and so let's talk about that. So first of all, asteroids are, the main belt of asteroids exists between Mars and Jupiter, and as Tom Jones will tell you, there are literally millions and millions of asteroids in the main belt, but we're not talking about those today. We're talking about the near-Earth asteroids. So these are asteroids that exist in co-orbital locations close to the Earth as they orbit the Sun in a, let me make sure I can click slides here, in locations that are easy to reach energetically from the Earth, in locations that are not far and certainly not nearly as far as the asteroid belt. And of the near-Earth asteroids, there are really two types, or at least two main categories of materials that we think are extremely valuable. So the first is water. Okay, so water in space, as you will come to learn, is perhaps the most valuable of the materials that we will use and find in space. Obviously, it's something that's critical to our life on Earth, and of course it will be critical to our life in space. But what we also need to realize is that water and its constituent elements, hydrogen and oxygen, are the most efficient forms of rocket propellant and rocket and oxidizer, fuel and oxidizer. The space shuttle, of course, ran off of liquid hydrogen and liquid oxygen. It is the best rocket fuel out there. And so being able to go to asteroids and mine them for water provides us not only, as I will show you right here, not only with the ability to support life in space, drinking water, food, growing food, protection from radiation in space, but also propellant, fuel, and oxidizer that will allow us to open up deep space for human and robotic exploration, to drastically reduce the cost of space exploration. So we'll come to that in the concluding remarks. The second most valuable materials that we're going to find in space are the precious metals and the materials that are very difficult to find on Earth. We have a joke at Planetary Resources, and that is that, hey, what's the big deal? We've been mining asteroids for centuries. We've been mining them on Earth. That is because the areas on the Earth's surface where we will find platinum group metals, for example, are areas of asteroid impact. They're places where asteroids struck the Earth millions and millions of years ago, and there are still tiny remnants of platinum group metals. Platinum group metals do not occur in the Earth's crust. By the way, these are some of the most expensive materials known to man. We're talking about $1,500 an ounce. Okay, so it pales, the cost of a pound of platinum is actually far more expensive than the cost to put that pound into space. And there are only a few things for which that is true. So the platinum group metals are something that will be extremely valuable for the future of humanity. These are materials that are very useful in all sorts of industrial applications, and all those industrial applications in which they are useful have to reserve for only the most important part of that element, whether it's a catalytic converter, a medical device, or some sort of microelectronic. They have to reserve the tiniest amount because it's such an expensive metal. And so as we go into the future and bring back eventually these platinum group metals, we will create abundance. And we will be in a position not unlike if you go back and look at the history of aluminum 200 years ago, where aluminum was the most valuable and, in fact, the most treasured metal because we had so much of it on the Earth, but it was inaccessible. We didn't know how to extract it from its oxides. And so once we figured out how to do that, it became abundant. And now if you look out here in Boeing Field, we build airplanes and cars, and it's all over the place, aluminum, because it's useful. And the platinum group metals will be no different. So we will bring the ability to access these metals into our economic sphere of influence. And so asteroids are very high in both of these kinds of materials, among many others. Obviously, you've heard about asteroids and the nickel content and the iron content, and all these things will be useful. But in particular, the water that will fuel an in-space economy, and then the most rare and precious of the metals, which we will eventually bring back to Earth. So, so let's move on to the second point, which is our plan. So we want to talk about how are we going to do this? What is the plan for asteroid mining? So there are really three parts to the plan for asteroid mining. We have thought and gathered together the most experienced and intelligent people, at least a group of these people who have done deep space robotics. Our team includes people who've landed spacecraft on Mars. We have talked and thought about the most important pieces of technology that will enable us not only to go to the asteroids, but to eventually extract resources from them. And so we have a detailed technology roadmap that we will use to get there, and we're going to develop these capabilities. And Chris Lewicki, who's our chief engineer, will get into the details of some of these capabilities and the kinds of things we're talking about. But overall, we have created a line of spacecraft. So the line of spacecraft is called the Arcid line. And Chris Lewicki will tell you more about that line of spacecraft. But the Arcid line of spacecraft will be used for first prospecting and then extraction. So as we talk about the phases of our business, phase one, is to fully develop our technology base and start with our initial line of spacecraft, which we will be launching within 24 months. Second, did you like that? As a brief aside, I love that you did that because this company is not about paper studies. This company is not about thinking and dreaming about asteroid mining. This company is about creating a space economy beyond the Earth. It's about building real hardware. It's about doing real things in space to move the needle forward, not just talking about it. We've done enough of that. There's plenty of talking. We're about doing. And so we want to be held accountable for that. We want to generate interest all around the world and have the public follow us as we really work to do a very hard thing, which is to create robots that go into deep space and learn to remotely mine asteroids. And so we're going to do that. It's going to be very difficult, but we're about doing it. And there will be times when we fail. There will be times when we have to pick up the pieces and try again. But we are going to do it. We're not going to talk about it.